See, in the previous video, we have seen overlappings possible among S and P. See, overlappings possible among S and P. One is what? S overlapping with S. Other one is P overlapping with P. And the third one was what? S overlapping with P. SS, PP, SP. Actually speaking, overlappings are of two types only. Now, what confusion is this? You may be thinking, isn't it? Nothing confusion. Overlappings possible among S and P. So, how many overlappings are possible among S and P? If you say there are three: SS, PP, and SP. Altogether, overlappings how many actually? Only two. One will be end on end, other one will be side on. Look at the board. Overlappings are of two types. One is end on end. One end overlapping other end. Other one is what? Side on side. One side is overlapping other side. So just now I was telling that overlapping is possible among S and P are how many? Three. Do you know the interesting thing? All these three come under one category only, end on end. Check it out: SS, PP, and SP. Now you understood? So these are overlappings possible among SS, PP, SP. So all these three come under the same category. So there are two types of overlappings: end on end, side on side. So you just check here: end on end. Just simple say end, part of one orbital. That's a extra word you're adding here. Overlaps with see end, it is end, isn't it? End on end. So here we are going to add something after end. What is it? Part of one orbital overlaps with, that much only. So here end part of one orbital overlaps with end part of another orbital. End on end overlapping takes place and the resultant is sigma bond. It is similar to S overlapping, PP overlapping, SP overlapping. Same sentence. S part of one orbital overlaps with S part of another orbital. Same. End part of one orbital overlaps with end part of another orbital. End on end overlapping takes place, resultant is sigma bond. You can see here, this is end of S orbital. This is overlapping end of another S orbital. So you got here sigma. This is end part of P orbital. This is end part of P orbital. So you got sigma. This is end part of S orbital. So this is end part of P orbital. You got sigma. So that's what he is saying. End part of one orbital, if it overlaps with the end part of another orbital, end on end overlapping, it is told that it is end on end overlapping and you will get sigma bond. Exactly, you got sigma bond. Here, the extent of overlapping is more. The overlapping area, as I told you, this is called overlapping, one upon the other. So in this case, it is said that the extent of overlapping, that overlapping area is more. The overlapping, so suppose if I catch like this, no? See, look at this part, this much part is overlapping this part. So here the extent of overlapping, this is very strong, you cannot break it, he say. The extent of overlapping is more. Extent of overlapping, that overlapping area is more. Therefore, this bond is strong. And next is, this bond can exist independently. Can exist independently. You should understand, very important point. Before explaining this one, I'll go to side on. See, end on end, what did you say? End part of one orbital overlaps with. I told you part of one orbital overlaps with is the extra line. Same it is. Side part of one orbital overlaps with side part of another orbital. Side on side overlapping takes place, resulting is pi bond. So this is sigma bond, this is pi. When will you get this? So first what you get will be end on end only. Due to end on end, what is it? You got sigma. Now after getting sigma only, you will get pi. That is what this says. I told you no just now, I'll explain you this one. See, this bond can exist independently. If you have one vacancy, first you will get sigma only. You will not get pi. First you will get sigma, then comes pi. That's why first you get is sigma. So it can exist independently. One vacancy is there means you will find sigma. To get pi, suppose I'll draw pi over here. Here I can show you. See, this is pi. Side on. This is called side on overlapping. Side on. So you got like this. This is pi. So this is pi like this. Okay, like pi. See, to get pi, first what comes is sigma. That's why it can exist independently. But if pi has to form, sigma will come automatically. Therefore it cannot exist independently. Suppose pi want to occur, compulsory sigma will come, then only pi. Therefore this depends upon sigma. Therefore it is called cannot exist independently. This can exist independently. The next one is, here the extent of overlapping is less, so pi bonds are weak. Sorry, pi bonds are weak actually, like this. As such, where is a connection? Suppose you use shake hand to anybody, this much only. Tuck, they can break them, okay, easily. But when you give shake hand like this, the extent of overlapping area is more. Down also you can see, up also. This one. So the extent of overlapping area is more here, more. So this bond is strong. Which one? Sigma. Pi bond is weak. So finish once again, just once. End on end. See, part of one orbital overlaps with is the extra line. That's all. End part of one orbital overlaps with end part of another orbital. End on end overlapping takes place.